So W means the weight of the pipe, weight of the fluid inside the pipe, weight of the insulation, weight of the valve, weight of the flange, insulation, weight of the cladding, whatever. So WW means weight of pipe, mean fluid density plus the water density is equal to water. We have to do the hydro test for each pipe, so that's why it consider water density. Water density is the maximum in normal industry practices. So WNC is weight with no contents, without any fluid inside the pipe, what will be the weight of the pipe. H is always defined for the hanger, spring hanger or spring hanger force. P is the pressure. 9 different pressures conditions can be input from P1 to P9. HP is hydro pressure, hydro test pressure. T is the temperature. 9 different temperatures conditions can be input from T1 to T9, as I told you in the input listing. D is the displacement. 9 different displacement conditions can be input from D1 to D9. Wind force, 4 different forces in 4 direction. Wind 1, wind 2, wind 3, wind 4. Plus x, minus x, plus z, minus z. All these directions the wind can blow. So we have to define all 4 directions. U, uniform load. 3 different uniform loads, ux, uy, uz, can be input as UDL, uniformly distributed load, or in term of gravitational acceleration. Both the options are there, so normally we go with the gravitational acceleration. F is the force. 9 different forces conditions can be input from F1 to F9. Again, let's come back over here. How to build these load cases? In this case, I'll go through first the load cases, and then I will explain you how to build these load cases in CAESAR itself. So let's discuss first about the load cases. So after defining the symbols and the alphabets, what is the meaning of W, 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 HP or W plus P1, T1, all these things. So let's discuss in detail about the load cases. So in CAESAR, you will find the load case number like L1, L2, L3, L4, L5, like that. It will be a series. L1 means load 1, load 2, load 3, load 11, load 12. Why it is required? It is required when we will build up the load cases, and when we'll do the algebraic sum or scalar, then it will help us. We have to subtract and we have to add these load cases. So that's why it is defined in L1, L2, L3, L4, L5, like that. Second column, you can see the load cases. WW plus HP is the first load case, water filled weight plus hydro test pressure. So this is called the hydrostatic case, and the code condition in hydrostatic case is that the sustained load should be less than the yield strength of the material. Here is the important point. See, here the code allows the sustained load should be less than the yield strength of the material, yield stress of the material. Here the factor of safety is not there. Mean to say, when we are calculating the thickness of the pipe and we are performing the hoop stress calculation, in hoop stress calculation we are considering factor of safety, and based on that factor of safety we are multiplying that factor of safety with the allowable stress to get the allowable stress. That factor of safety we multiplied with the yield stress, and after that we are getting the allowable stress, and that allowable stress we are using in wall thickness calculation. But here in hydro test, that's why in hydro test normally we goes 1.5 times of design pressure, because when we perform the hoop stress calculation we consider the design pressure. If we go beyond that, then the thickness should fail, right? But it's not failing. Why? Because here we consider the allowable yield stress, not the allowable stress which is having a factor of safety. So this is the difference between the allowable stress, and here in hydro test we use the yield stress. So this is the code criteria that sustained stresses should be less than the this yield stress of the material. Here we have to check in CAESAR the stresses, forces and moments, and the displacement. Okay, here the dy, the vertical displacement in this hydro test case, it should be less than 10 to 15 mm. It depends on the company to company. Some company allows 10 mm, some companies allows 15 mm vertical displacement downward minus. It should be less than this, and the stresses should be within 70 to 75% of the allowable stress. So this is a general industry practice, but this is the code equation. Then second load case is W is the weight of the pipe, P1 is the design pressure, and T1 is the design temperature. So this is called the operating case. case, and there is no equation as per the code. Code don't give you any allowable against the operating cases. If you consider the operating case as occasional case or sustained case or expansion case or like that, with the combination of those, then it will give you the equation. But exactly for the operating case, there is no equation as per the code. So in this case, we don't need to check any stresses because there is no allowable stress against this. We have to check the forces and moments at the node points, either on the flange connections where we have the equipment flanges for the nozzle evaluation, at the node where we have the pipe supports. So forces and moments and the displacements. Then third load case is W plus P1 plus T1 plus WN1. W is the weight of the pipe, design pressure, T1 design temperature plus wind 1. Wind 1 means operating case plus wind. Wind in one direction, wind in second direction, wind in third direction, wind in fourth direction. Direction 1 means maybe it is in X direction, this is minus X direction. This is minus Z direction, this is plus Z direction. So wind can blow either east west or north south. So based on that, we are applying in all four direction along with the operating case. So wind plus operating case. Again, against this, there is no equation in the code. So no stress check is required for these cases. Only forces and moments and displacements. After that, it is continued till L3 to L6. Then L7, W plus P1 plus T1 plus U1. U1 is the seismic. In case of earthquake, the earth can vibrate in plus X minus X direction, plus Z minus Z direction. So based on that, we are applying this L7, weight of the pipe, design pressure, design temperature, and U1 direction. This is seismic. Then W plus P1 plus T1 minus in the opposite direction, plus U2 plus Z direction or minus Z direction, like that. Again, against this, there is no allowable stresses, so no need to check the stresses in this case. Only the forces and moments and displacements. Load case 11, W plus P1. This is called the sustained case. W is the weight of the pipe plus internal pressure of the pipe. And during normal condition, this is the load that pipe supports has to sustain, weight of the pipe and the fluid inside the pipe. In this case, this sustained stresses should be less than the hot allowable stresses. And here we have to check the stresses as per the code. This is the code equation. We have to check the stresses, we have to check the forces and moments, and we have to check the displacement. Again, in many companies, this in this case, sustained case, the dy should be less than 10 to 15 mm. Again here, as per the industrial practice, these stresses should be less than 70 to 75% of the allowable stress. L12WNC, weight with no contents, mean weight of the pipe only. So this is called the sustained. Again, the same criteria applies and same stress allowable stress criteria is applied here as well. Then L2 minus L11. L2 means this is the load case, L2 minus L11 and minus with this. So what is left? Only T1. So here we are checking the thermal expansion. If you subtract from here this L2 minus L11, so W will cancel out with W, P1 will cancel out with P1, only T1 left. That is called the design temperature, which is expansion case. So here we have to combine it as algebraic, like minus 5 plus 10 is equal to plus 5. So this should be, as per the code, SC should be less than SA, which is we already know as per our part 2 detailed discussion. So here again we have to check the stresses. Force and moment is not required in this case because this is expansion case. Only the displacement is required. No specific limit, but displacement should be less than 75 mm and have a closed look. If it is more than this, then normally we go with the expansion loops. So in separate part, I will explain you when we require the loops and where we require loops, and it will be a separate presentation regarding the loops. So in this case, again, the 90% if liberal not used and 80% if liberal used. There is option in the Caesar software, we can use the liberal stresses and we cannot use the liberal stresses. There are two things, and both these cases, the allowable loads with liberal, allowable loads without liberal stress, it is allowed as per the code under certain conditions. But most of the companies, they don't allow to use the liberal stresses. That's why we have to uncheck that this is the software, and then we have performed the analysis. Then L14, L3 minus L2. L3 means W plus P1 plus T1 plus WN1. So L3 minus L2. What is L2? L2 is this, right? So if you minus this from this, W will cancel with W, P1 will cancel with P1, T1 will cancel with T1. What is left? Only wind. That's why it is called occasional case, pure occasional, like wind case. Here we have to again apply the algebraic. No equation is there for this case, so no stress is required to check, only the forces or moments and no displacement in this case. So these L3 minus L2, L5 minus L2, L6 minus L2, again all these are typical occasional pure wind cases in each direction. When we are checking the effect of the wind when the plant is in working condition and there is a wind blowing, so what will be the impact of the wind on the plant piping, whether it will fail or it will sustain the wind forces. So we are checking in each direction, x minus x, z minus z. Similarly in seismic, L7 minus L2, L7 minus L2, again W cancel with W, P1 cancel with P1, T1 cancel with T1. What is left? Only seismic, U1. Similarly minus U1. Similarly U2 minus U2. So these are the 4 pure seismic cases, occasional seismic cases. Again algebraic sum. This is type of the combination we have to mention in the Caesar, whether it will be the load combination will be algebraic or scalar. There are 2 types actually. Algebraic means it will take the algebraic. I mean, if minus value and plus value, it will detect it and it will give you the net result. But in scalar, it will add whether it is minus or plus, it will add both the values. So again, no stress check in this case, only forces and moments and no displacements. So similarly L22, it is a combination of L11 plus L14. It means it is the occasional case where sustained plus wind. L11 is the sustained case combination with wind. When in case the plant is in sustained condition, operating condition, and wind is acting, so again the scalar, it will be a combination of scalar, okay, that when the plant is there and wind is also there, so both effect will be there. So that's why we are not taking the algebraic, but we are taking as a scalar sum. So in that case, sustained plus S occasional should be less than 1.33 times of Hart allowable stress. So this is the code equations. Here we have to check the code, and no force moments and no displacement required. Similarly, it is required for all 4 wind cases, all 4 seismic cases, and same equation is there from the code itself, and we have to check the stresses in all these cases. So this is a very simple example, but in actual, like this case, we have to define maximum design, then operating, like W plus P2 plus T2, then W plus P2 plus T3, like that we have to define, like maximum design temperature, operating temperature, and minimum design temperature. So in this way we have to define in all the load cases, and all 3 cases, then again we have to apply the winds and seismic, and then we have to come up with these kind of load cases. So this is how the load cases are in the Caesar software. And let's go back to the Caesar, so you will be familiar how to define the load cases in the Caesar itself. How to build up these cases in Caesar software, let's discuss now. So these are the icons, as you can see here. You can save the load cases, you can print these load cases, you can add these load cases. When through this icon you can add the load cases, through this icon you can remove the load cases. So these are the 4 icons where you can have addition and deletion of the load cases, print and save. Then after that, these bar you can see load case addition. I mean, you can edit the loads T1, T2, T3 as defined over here. You can edit it by clicking the load over here. We'll do the practical experience when we'll actually perform the stress analysis. Okay, when you will click over here, you can edit all the load cases. Similarly, you can go to the load case options, and in the load case options you can define the wind, the wave load cases, all these load cases you can define over there. And again, when you will click each, it will open a window, and there you have to define the wind forces, velocity of the wind, and height of the wind, like at what height what will be the velocity. With respect to the height, the velocity of the air will be, or speed of the air, and the impact of the air will be different. There are 2 options in the Caesar where you can define it, the wind load cases. Then this icon, if you click, it will give you the recommended load cases only.